This
So,
conference will now be recorded.
okay. So the first question is, what is Docker? Now, you have any idea about the Docker? Do you have any idea?
No.
Okay. So let me put it in this way. If I see Docker, Docker is a container, okay, management tool. Okay. Now, before that, I must tell you, like I'm not covering all through the slides because just I don't want to drag your hours, my hours also. But all the slides you can find at this place. Okay. So any slides if you're looking for, here you will find it. So let's say Docker slides are here. Okay. So you can use this also. So coming back to the points now, what is Docker? So Docker is a container management tool. Now, first question is, what is the definition of tool? So I think you know that, right? Tool will save your time. Simple. Any tool. You are using any tool, so save your time, save cost, and improve quality of your work. Correct now? These are the this is the reason you are using humans are using a lot of tools, various
Right.
tools. So now you'll ask Rajesh, forget about all the tools, talk about how the Docker will save my time, how Docker will save my cost, how Docker will save and I'm sorry, improve quality of my work. So let me put it up in this way. Let's say you want to run your applications. Think about it. So earlier you want to run one applications. In the world of physical server era, how much time you are spending? If you want to start, procuring hardware, then install operating system, then middleware, runtime, then application. How much time it will take? So you used to spend almost one day, 8 hours of time. I'm just hypothetical scenario, right? So physical server. Then what you did, you migrated to virtual server. Virtual server means what? AWS, VMware, Azure, Google Cloud. If someone asks you, hey, go ahead and set up applications, how much time you required? 5 minutes. Correct now? So now if you use a Docker, you can run one application in 1 second. You can run thousands of application in 1 second. So tell me, am I saving your time or not?
Yes.
So how it is possible? That is a different question. But if someone will ask you, hey, what is the fundamental reason why we should go ahead for the Docker? So one of the reasons out of many reasons are it is saving our time to set up environment, set up running application. You want to run application, use a Docker in a container. So run that in a container and then you save your time. Now, next question, saving cost. Okay, saving cost. So how you, if you are running application in a container using Docker, how it will save cost? So let me put it in this way. So let's say if you are running the the application in a physical server, here I should just write physical server, virtual server, and container. Okay, so that way you remember that container. Here it is. So if you are running application in a physical server or virtual server or container, let's say how much CPU you need. So remember that in a physical server, in order to run up application, let's say Apache, you need operating system, right? And then you need application. Agree with me, right? Correct now?
Correct.
Now, if you run application in the virtual server, you need operating system and then you need application. Correct? So now the question is, you required one operating system to run this application. This application can be Apache, Tomcat, Java, Python, PHP. Literally, it can be anything. Okay, Pritesh, are you there, right? You have joined, right? Okay, okay. So uh, save cost. So here, what about if I tell you you can run app in a container without operating system? Then how would you say? No OS, without OS. How it is possible? We'll discuss later. So tell me here. Remember that in order to run operating system, don't you think you need a CPU, RAM, storage, licensing cost? Here you can minimize that cost. So if you want to run app in a container with, so container has no operating system, so that way you can save cost. Are you understanding how it can? So resource cost, CPU cost, RAM cost, storage cost, license cost. This is a cost, right? So if you think one application that way, think about in data center. How many applications you run? Thousands and thousands of application we run in data center. So saving cost, correct? No? Hello.
Yes. Yes.
Now how it can improve the quality? So not only I'm saving your time, not only I'm saving your cost, whatever the saving you have, where you spend, tell me. Let's say you want to set up a dev environment, 1 second. If you want to set up a QA environment, 1 second. If you want to set up a production environment, 1 second. So easy now. You know, whatever you are running in a dev, you are running in the QA. You are running in QA, you are running in production. Earlier we had a lots of gap, right? It's working in a dev, not working in QA. It's working in QA, not working in the production. That challenges will not be there with the container and Docker technology, because whatever you are running in the dev, same thing you will run in the QA because of Docker image. I'll come back to that Docker image concept and all. So you are saving lots of time. So where you will spend that time which you saved as an engineer? So of course you'll saved on the improving quality of the software, right? You will do the better coding, you will do the better testing, correct now? So that way it is improving the quality of your software. So tell me, using this tool, can we not get all this advantage?
Yes.
Okay, so now they now you if someone asks you, hey, why we are using Docker? So I think you should be having the answer for it. Now next question is, okay, tool I understood. What is management? So management means what? So management means something like, say, have you worked with any VMs technology? VMs technology, VMware.
No.
Okay, so right now I think you have got to know some idea about the AWS, correct now?
Yes.
So in AWS we have a EC2 VM. EC2 is like a VM, correct now? So what you can do with the VM? What can you do with the VM? So VM you can create start, stop, restart, start, stop, start again, restart, pause, unpause, correct now? Kill, remove. These are the things you can do that. Same thing we can do with any VMs actually. Any VMs like VMware or anywhere, Azure also. So here, when I say management, means Docker is managing a container. That's a different question. But managing what? So Docker can manage your container. So it can start the container. It can create the container. You can start the container. You can stop the container. You can do all this thing, whatever I have mentioned actually. Very simple. So if someone will ask you, okay, fine. I understand the advantage of Docker, but what can you do with the Docker? So you simply say, hey, I can create a container, start a container, stop the container, restart the container, pause, unpause, kill and remove. It's the same thing, something we were doing earlier also from last 20 years with the VM technologies. Correct now? Hello?
Yes, sir.
Yeah. Vipul, are you understanding, right?
Yes, yes, yeah. Okay.
So now next question is, what is container then? This is the important question, because Docker will ultimately manage the containers, right? So what is container? So I'll try to help you and explain in a simple way instead of getting into the kernel and deep dive into that, because that is not going to use. So see here, simple. The important question is how we run applications. That's the important question. So if I ask you, hey, run some application, XYZ application. So then you'll say, Rajesh, I need one hardware. Okay. Okay. After that, okay, fine. I gave you hardware. What do you need then? Then you'll say, I need a OS. Okay, then fine. I give you the OS. Then what do you need? On top of OS, I need some runtime in libraries like Java and all. That is fine. You need a, oh, sorry, but I did. So you need a runtime library, and on top of that, you will run application. Simple, correct now? Agree with me? This is the hardware.
Agreed.
This is the kernel OS. Okay. What is happening? Why is moving so fast? Kernel operating system, and then here it's a Java, and then application. Correct now?
Yes, sir.
So now the question you should ask a little bit more. Hey, I want to know a little bit internal actually. Because why you need to know internal? Because you need to know understand the container. What is a container? So guys, you know what? In order to run an application, you know what? At least one user is required. User is required. Yeah, one user is required. From where it is coming? Look at this Windows itself. Don't go far in Linux. Look at this. These all are application I'm running in the Windows. See, no, this services. This is the application I'm running. See, this is the go-to meeting I'm running right. Why is running so fast? Okay, forget about just random any applications. And look at this here. Look at this very carefully. Okay, see, this is the application I'm running, and it's run by Rajesh user. This application I'm talking about is run by system user. See that hell lot of application I'm running. Do you see any application without a user? Correct? Hello?
Yes, sir.
Yeah. So that means in order to run application, you need a user. That's fine. That's fine. What else you need? So understand that this application which you are seeing here, Firefox, it required what? File system also, right? Where you will save. So this is typically save in the C programs files. You all know that, nothing great about it. But in a computing terminologies, what do we call it? So we call it a mount. We need a mount. Mount means file system. Mount. Correct now? M-N-T. This is a user. Okay. Then what else you need? Then this application, in order to run this application, you need a CPU and RAM. Look at this here. This is the CPU and this is the RAM. You see? Here it is. So you get a CPU resources and all. What else you need? You need a PID, process ID. Without that, how do you get a CPU and RAM? So there is a one PID tray is there, resources, which will give you the process ID. Okay. So user, mount, PID. Let's say some of the resource, some of the sometime you know what happens. Some resources are network intensive resources. That means Apache, MySQL. It required a network. So in that case, they host the network also. So you need a network. So that means if you ask me, Rajesh, can you tell me which resources you need to run applications? So I would say, hey, we need a hardware. Then we need an operating system which has a kernel inbuilt. Then we need a one user, one mount, PID, PID resources, process resources, network resources, and then only you can run application. Are you fine so far?
Yes, sir. Yes.
So the question is, from where is this resources, this resources, this resources, this resources is coming? You know what? These all resources is coming from the kernel. Yeah, this is the same kernel. Kernel. Simple. Okay, let me show you one image which will help you to visualize in easy way. I'm not hitting the slides because it will consume time. Look at this here. Perfect image. I like this. Though it's a little outdated, but more than what you can consume. See here. There's a kernel. C groups is there. Namespace is there. Capability is there. SC Linux, NetFiles, all these things there. Now namespace is important. Okay. Namespace. Where is that? Here it is. Look at this image. Namespace. See namespace you see here. PID. PID I told you right. PID here somewhere I told you right. PID. See here. Here. MNT. User. Net. See all these images. PID. MNT. UTS. Network. IPC. All these things. So everything is in kernel. So kernel is creating user, MNT, PID and network. Now the question is, can kernel create a more separate resources? The answer is yes. Kernel, because of virtual resources, you can create as many. Anyways, user you can create multiple, right? Rajesh, Rakesh, X, Y user you can create. So multiple mount also you can create, multiple pit tree also you can create, multiple network. Who will create? Kernel. Okay. So this is how little bit of computing discussion. So this is how it works. So the question was how to run this application. You got an answer, right? All of you.
Yeah.
So now the question was, what is container then? So let's understand in a different picture. See here what happens. There is a hardware, and then on top of that we have a kernel, which is an operating system. Remember that kernel is everything. This guy can do everything. See here. This is a kernel. Remember this image. Kernel can create multiple user. Okay. Multiple user, multiple mount, multiple PID, multiple network. So there is one guy. What is the name of this guy? This guy, Solomon Hikes. I remember now this name. Most of the time I forget, but today somehow my memory is working. Hike now, yeah. Is this the one? No. Solomon Hikes. Let me find out. So this guy, Hike. Okay, Solomon, yeah, sorry. Solomon, that's correct. Hikes, correct. Solomon Hikes. This guy. So this guy created one applications. So it is running on top of kernel, you know, and this application which is running, this guy, this application is asking kernel, hey kernel, can you create one user? Yes, why not? Can you create one mount? Uh, why not? Can you create one PID? Why not? Can you create one MNT? Why not? Remember, these all resources created by this kernel. And something similar, more request has come. One more, and many more. Remember, then remember that this is a Rajesh. I'm giving the username. This is a Bipul. And this is a Pritish. 3 users. I will ask you in simple scenario. In my laptop, if I have a 3 users, how many C drive you will see? How many? Hello?
Yes, sir. One.
Hello? 1, right? But you forgot that here we have a separate C drive, separate C drive, separate C drive. That means Raj has a separate C drive, Vipul has separate C drive, Pritesh has separate C drive. Okay? Why? Because kernel has all this capability to create. So now here I can run Apache, this guy can run MySQL, this guy can run Tomcat. Remember, Apache is in their own different mount location. This is the same, this is the same. So this is isolated environment, not sharing the libraries. That means in order to run Apache, whatever resources you required is already managed. Now, what we call this one? So this is a container. This is a container. This is a container. So what is a container? So container is a application runtime environment. Container is application runtime environment, and that environment contain all the resources independently from the others. Simple. Who's creating container resources? Kernel, kernel, kernel. Tell me in this how many operating system you have?
Isolated 3, right?
No, only one. No.
Oh, in kernel, yes, one.
Yeah, only one. So remember that earlier what you were doing. Earlier I wanted to run 3 applications. So you are running 3 VMs, 3 operating system. You see that here? One application, one VM, one operating system. But here in container, no operating system. Why? Because all these container share the same kernel, share the same kernel. So one up. So less utilization of CPU, RAM, and storage. And but isolation. This Apache has their own C drive. This Apache has their own C drive. This Apache has their own C drive. Why? Because mount is separate, mount is separate, mount is separate. Who's doing all this thing? Kernel. Kernel has all this capability. We call it namespace. Namespace. Which namespace? PID, MNT, IPS, and many more. Now you understood this, all of you?
Yes.
So now question is, what is container? So technical definition, container is a lightweight. So avoid the spelling mistake. Application or runtime environment. Simple. Why we call it lightweight? Because container consume lesser CPU, RAM, and storage in a no operating system. So it's a lightweight for what? Application, of course. And it has a complete runtime environment. That means it has everything. What it has? It has a network also, mount also, PID tree also, user also, application also. Everything is isolated, independent runtime environment. Okay. Else, if you say this is a functional definition, okay, and if you say technical definition, then you can say container is nothing but uh, uh, one user namespace, one network namespace, one MNT namespace, one PID namespace. This is the technical definition. Technical definition means which you can refer from this image. See, there's a namespace and then attached to this. So, did you understand that, all of you?
Yes, sir.
People?
Yeah, I'm good. Thank you.
Okay, so now the next question is, okay, fine. Now no more jargons. We'll start using it. If you are interested in knowing more internal details, check out my kernel videos. Okay, So let me show you my videos kernel, so you will understand a little bit better way. So here you will find the, let me log in first. So go to the Linux here, and the Linux here I have some uh, Linux fundamental. So many videos are there, but I think that this one is not organized correctly. So I need to spend some time here. Go to the DevOps, and here, see here, this video, Linux kernel. So spend some time more, understand the Linux kernel, and you'll get it. Okay. So now the question is, okay, fine, what to do now? So the next question is how to install Docker. That's the question. Okay. How to install Docker. And for that, what I'll do, I'll just type Docker. Okay. Install. And for all of our lab, we'll use Ubuntu. Okay. So Ubuntu, and at every requirement, whatever you need, some manuals and all, at the end of it, just put the Debugschool. So you will find my dedicated tutorial. You see how to install Docker in Ubuntu, and this is the one. So these are the command line which you need to run in Ubuntu to install Docker, and this is the same command line but is embedded in the content. So this is the way you can install Docker. Okay, I'll show you the demo. Don't worry about that. After that, components of Docker. Components of Docker. What are the components? So you can say components of Docker and then Docker architecture. Docker architecture. Someone will ask you, hey, what is architecture of Docker? So then you have to answer this. So you can say in every architecture, we are always there. Human always there, and we talk to the Docker client. Okay, there's one utility, Docker client, and Docker client talk to Docker daemon. Docker daemon, sometimes you call it a server also. Okay, this is a server. This is a server, and Docker server, Docker daemon talk to the container D. Now you'll say, Rajesh, Docker was okay so far, but how come you added container D? What is container D? So this container D basically is one of the library which is for creating a container runtime. Now you see, this is the industry standard. That means anyone who wants to create a container environment, they need to use the container D now. Earlier there were so many container runtime, so we got confused, lost, development got in a different direction. So now they have come up with the common one, industry standard container runtime environment. And the container D will talk to whom? So they will talk to kernel, and kernel will get you everything. Okay, so now the question is, when you install Docker, what you get it? So when you install Docker, actually, you know what? You get this client and server. And what do we call it? Docker engine. The funniest thing is, I'll tell you, Docker is not at all any product name. Also, Docker is not at all a tool name also. Then we'll say, Rajesh, why you are teaching me Docker then? Actually, you know what? I'm not teaching you Docker. I'm teaching you Docker engine. Then question is, what is a Docker? So Docker is nothing but a company name, and their first product itself named with Docker engine, but it's become so popular, so everyone started calling Docker, Docker, Docker. But Docker is a company name. They have a multiple product exactly. Docker engine is the first and most popular product of Docker, developed by Solomon Hykes. This tool has been developed in Golang, uh, and this is open source actually. Understood now?
Yeah.
Okay, so here we will install the Docker engine using this tutorial and so on. Now you say, Rajesh, I want to learn Docker. What to do? So I will say, you have to learn the 4 components out of which. And if you're okay with the 4 components, then you are able to learn Docker. What are those? So the first component is Docker engine. You have to install in some operating system. Linux primarily, Windows also you can do that, but Linux, let's start with it. Windows, when I say not an older version of Windows, anything which is more than 2019 will support a Docker in Windows environment. So first you have to install the Docker engine, which I will install while demo. Then second thing you have to get Docker image. Okay. Then you'll say, Rajesh, what is a Docker image? Now, you know what? Uh, for time being, till you understand the anatomy of Docker image, I'll make it very easier. Okay. Let's make it very simple. You set up a operating system in a physical server. So what you do? You have a OS image, right? Correct, no? OS image you install in the operating system physical server. Correct, no? Agree with me, Vipul?
Yes.
So if you want to set up a VM, then you have a VM image also. Same thing. This is the VM server, VM image, right? So now the question is, what is a Docker image? So Docker image. So if you want to have a container, those containers environments what? Whatever the mounts you see, sorry, not here. Whatever the mounts, application basically, and mounts, everything you have in the Docker image. Docker image, that means whatever the application you want to run, and again I'm repeating, whatever the application you want to run, that application plus their required environment is in Docker image. Simple. So Docker image consists of the files and folders, directories of the application and library required to run that application. Now we'll say, Rajesh, I am not able to understand this. Give me a technical definition. So let me put it up in this way. So in any image, what you usually have, you have a file system. Okay, file system. What kind of file system? So there is one file system called boot file system. Boot file system. Boot file system. This file system will help you to boot the operating system. And after that, root file system. Okay. So boot file system, something like a kernel. Kernel itself is a boot file system which will help you to root the machine, boot the machine. Root file system, what is that? Let me show you rather than talking, because if you see that, it'll be easier. Visualizations, and just put the Debugschool. Okay, it'll be easy. See, and tell me, have you seen this kind of file system anywhere?
Yes.
Yeah. So this is a root Linux file system, and Windows also. Let me show you my computer. If you go, oh, whatever that, where is my computer? Here it is. So if you go and see, these are the root file system. We'll start with root. PC, C drive, Windows, program files. These are the Windows one. Okay, so these are the root file system. Look at this detailing actually. So these are the root. Kernel is a boot. On top of that, what you have? User file system. User file system. Have you seen the user file system? Every day you see that. Let me show you. Go to your user home. This is my user home, Rajesh. See? Have you seen this file system every day? Desktop, my documents, download, this, that, all that, right now? And then you have next one, application file system. Application file system. So what is application file system? So application file system means, see, this is my laptop, right? What you are running? You know what? Everything typically I run in the C tools. That's my habit. Let me show you. I run in C tools, all the application you see, these all are applications file system, but many applications are in programs files also, you know that. Nothing, I don't have to teach you all this thing basic. These are the application. So what are the application I installed in program files? I don't know what is this. Mail, Office, .NET, Movatech, Hyper PK, I don't know what is this. Mudra. Mudra installed for DSC once actually. Okay, So these are the file system. Now you understood now what is the file system?
Yeah.
So now you know what? Any OS image or VM image you will have all file system. Yes. Then you will say, Rajesh, in the Docker image, what it contains, what file system contains. In a Docker image, you do not have a boot, you do not have a kernel. That's the reason I'm saying this is a Docker container has no operating system because it has only root file system, means C drive, user file system, application file system. And they share the boot file system with the kernel, with the host machine. You see here is a boot file system. So there's a root file system plus user file system plus application file system. This is called mount actually. This is the mount. Understood now?
Yes.
So what do you call it a Docker image? So Docker image is nothing but a root file system, user file system, app file system, and that's the image you need to have it. So coming back to the fundamental question, how can I learn Docker? So first install it. Then what? Then get an image. Then you'll say, Rajesh, from where we get an image? So you can create your own image. That's easy. But yes, for not now, you can get an image from Docker registry. Now, what is a Docker registry? So guys, Docker registry is a conceptual keyword. Okay, there's nothing as such place name called Docker registry. For example, I'll give you simple example. Um, uh, uh, Bike, motorcycle is a conceptual keyword. But if you say Bajaj bike, then you are identifying that particular bike, right? Otherwise, every bike, no matter which company they are from, you can call it a bike. Simple. So Docker registry is a conceptual keyword where we use these terminologies where we store the Docker images. So there's many places, public and private registries are there. One of the registries which is very popular is hub.docker.com, and this place you will find a lot of Docker images. Now how many? I don't know. How many? Look at this. Somewhere it should be, earlier it used to be there. I think they have removed recently. More than lakh images you can get it here. More than lakh, 1 lakh images. It's removed actually that UI. Earlier it used to be there. Hell lot of images you get it. And you know what? Just name it. You will get those images. What do you want? You want MySQL image? Here it is. You want Tomcat image? Here it is. You want, let's say, Ubuntu image? Here it is. Any images you want to get, Python image, Java image, whatever you think of, you get an image already developed by someone, an official image, verified image, community image, contributed image, a lot of it. Understood now? Hello,
Sir.
Bipul,
Oh, yeah. Yeah.
focus. Okay, so now this is the image. Now next question is, okay, so if I want to learn Docker, I will install the Docker. I will get the image, but from where? hub.docker.com. Then what to do? Last one, nothing else. That's all. Container. Container. How? The moment, simple I'm making statement, the moment you run image, you get container. Simple. That's a 4 component you have. So if you run the image, how to run, I'll teach you. That's not a problem. You get a container. So these are the fourth element components you should learn, and you're done with it. Then rest of the time you need to run this command, the one which you have here. You create a container, start the container, stop the container, and blah blah blah. You have to do that. Make sense?
Yes.
Okay, so these are the total the theoretical part of it. What we'll do next session, I will install the Docker in front of you. This is the tutorial I'll follow, and after that we can create a container, start, and blah blah blah, all this thing we'll do and show you the demo for that. Okay, so tomorrow this will do that. Okay, any
Okay.
questions?
Not from me.